You're flying a kite when you notice that you have 300 feet of string out and the kite is 150 feet off the ground. What's the angle of elevation of the string? So here's your kite up in the air. And the string is coming down to you here. And you notice that at the point when you have 300 feet of string out, the height of the kite is 150 feet. Whoops. Assume this is measured straight up and down. This is horizontal. I'm asking about the angle of elevation, so from the horizontal up. I guess this kind of assumes that you're holding the string right on the ground. Well, maybe you're holding it with your toes or something. What's the angle? Well, that angle, these two sides, that's the opposite side and the hypotenuse, this should be the sine. So the sine of the angle is 150 divided by 300. So in this problem, I don't have the angle. I'm looking for the angle. And this is where we need to use an inverse trig function. So theta is the inverse sine of 150 divided by 300. I'm starting to feel like maybe I should be able to recognize this, because 150 divided by 300 is nice, isn't it? That's the sine inverse of a half. That's one of my nice angles, it seems to me. If I had 1 and 2, isn't the other side the square root of 3? So that should be a 30-degree angle. Let's see if my calculator agrees with me here. If I say sine inverse of 150 divided by 300, it says, yeah, 30 degrees, right? Sometimes you can recognize them. There's two nice triangles, right, which give us three nice angles, 30 degrees, 45 degrees, 60 degrees. And once in a while you run into an application problem where you actually do have one of those nice triangles. And you might be able to just recognize that angle without using the inverse sine. If this had been anything else, if I had said 140 feet and 300, well, that's not going to be a nice angle. It's not my nice 30 degrees. I'd have to use the inverse sine to calculate it. Okay.